Welcome everyone. It's exciting to be in this beautiful city. So first, for the first 30 minutes or so, we'll go over some of the architecture patterns. Probably these are some of the terms that you might have heard before, but to refresh the memory and set the context for the talk, we'll go over that. And then we'll discuss a little bit about managing and then deploying microservices. And then looking at how cloud-native applications or certain cloud-native applications can be developed. And then we'll go over some of the architectural, kind of analyzing architectural trade-offs. Because if you are working at an architect role, you've probably seen it's basically like a perpetual exercise of analyzing trade-offs for different scenarios to choose the right pattern, right abstractions, right characteristics based on what the constraints that you have already or the use case that you have to deal with. And then we'll dive into how a distributed application can be deployed on Choreo. And then we'll talk about that use case. And in the next follow-up session, we'll also do a hands-on session on how these components can be created in Choreo, and how they can be scaled, and how dependencies can be structured, and so on. So to get things started, broadly, these are basically kind of atomic kind of patterns. So there are like monolithic applications and then distributed applications. I will not spend about much. I'll give a brief kind of description about this. So monolithic is basically you have everything as a single, in a central, maybe a binary or executable. Still, you might have like some form of layered, like MVC pattern. And then there have been a lot of popular applications got started as a monolith. Like Twitter, for example, was like a standalone Ruby on Rails program for a very long time. Before they get to that scale. And also Cloudflare. Cloudflare started as a kind of a set of stored procedures written on top of a PostgreSQL database. But if you look at now, they handle 80% of the websites that's on the internet use Cloudflare in some form. And then, of course, pipes and filters. So pipes and filters is basically you have some kind of filtering mechanism, and then you filter based on certain conditions, and then you pass the data to another filter. There are lots of examples in this pattern. So WSO2 ESB is kind of using this pipes and filter architecture underneath. And then, of course, even though there are some cons into this, like WSO2, for example, have made certain provisions so that it's fairly easy to scale and then fairly easy to do HA deployments. But still, there are inherent problems that you get with monolithic programs. It's there. But if you look at different products, by different companies, different technologies, there are certain things that might be easier while keeping the monolith, that architecture. And then we, of course, another popular pattern, like a microkernel architecture. So in WSO2 also, if you look at how ESB and API Manager are structured, it's following this microkernel pattern. So we have a core kernel, and then all the capabilities are written as OSGI bundles, and then get plugged into the main kernel. So fairly easy to modify certain things and test individual functionality without having to test the end-to-end system. But still, it's a little bit comparatively harder to scale, harder to do HA, and so on. And then we come to distributed patterns. So for the longest time, SOA was very popular. But if you look at the complexities involved, each layer, even though it has a clean kind of layered approach, each layer had multiple WS specifications attached to it. So if you worked with SOA tools before, it's very complex. And then there are like XML, lengthy XML specs to deal with all over the place. But tooling made somewhat easier to deal with some of the abstractions there. And then, of course, event-driven is another popular pattern. There are lots of examples as well. That's products based on an event-driven pattern. One of the things is that main attractiveness of is that you can improve the responsiveness because it's asynchronous pattern, right? So you can fire an event and then just kind of forget about it, and then later on, when there's a response, you kind of react to it, right? And then with this pattern, some of the brokers, if you deal with the message brokers, etc., they were a little bit harder to scale. And then you had to manage, if you are doing fault tolerance, for example, you had to do like client-side load balancing for most of these brokers, maintain a set of URLs where all these brokers live. And then scaling, again, not that easy compared to a kind of a microservice pattern, right? And then there is this space-based architecture pattern as well. So the idea behind this pattern is that you have a bunch of processing units, and these processing units can be structured based on different domains, different functionalities, etc. And each of these processing units write their state into a kind of a virtualized middleware layer, which is a kind of a distributed cache, essentially. Even though this brings in a lot of performance into it, there are a lot of complexities when it comes to managing different state, being able to replicate this state across multiple nodes, and so on. So some example for this is basically a lot of the heavy transaction processing software tend to be based on space-based architecture. So we had a customer called StubHub. StubHub is essentially a kind of a ticket reseller, so basically. And then for the longest amount of time, StubHub was based on an alteration of a space-based architecture. And then they used memcached heavily as the distributed caching layer. So this is way back in around 2010, 2012 timeframe. This is before they moved into a kind of a microservice-based and then API-first architecture. And then, of course, we come to microservices, and then we'll talk about microservices as we go along. I'm sure a lot of you are familiar with microservices. And then, again, so there are pros to distributed architecture. Again, some of the pros becomes like cons as well. When you have a lot of microservices, it's kind of hard to debug and figure out. If, for example, if one call that originates from an application then gets transferred into like 7, 8 microservices, it's very hard to debug unless you have a good monitoring and tracing tool set available to you that allows you to trace requests end to end. Yeah, and then look at, and when you are developing microservices also, there are a bunch of patterns that you can use. I'm not going to go through every pattern. Like there are like decomposition patterns where you can kind of, when you get to a certain scale where you have multiple, like hundreds of microservices, you can use some of the patterns to decompose these microservices or group these microservices into domains. So we'll look at one of the patterns there when we do our hands-on sessions today. And then, of course, there are integration patterns involved, database access patterns involved, observability, etc. And then one popular pattern that we see is basically when you are transferring from a monolith to a microservice architecture. Usually this strangler pattern is very useful. Basic idea behind that is you take maybe 1 or 2 features from the monolith and then refactor it to microservices while keeping the monolith in place. And then as your time goes on, you take another feature and then transform that. So you'll see gradually the kind of the monolith gets like smaller and smaller, and then a lot of the microservices gets like bigger and bigger. And then microservices again comes with their own set of challenges. So you need to figure out how to package these microservices into like deployable units, and then how to do testing. how to do version management, how to do like config, secret management, scaling, monitoring, and so on. So here, a lot of the times that what we see here is that there are like promise of tooling that different vendors, different open source projects promise that, okay, we are doing this to make life easier when you are scaling, when you are managing a lot of microservices, when you are doing config management, when you are testing, and so on. So we'll get to that as well. So cloud native is basically, the idea is that you write your services to get full advantage from like an infrastructure as a service vendor, or like a popular known as these cloud vendors, right? That's usually the term that's being used to refer to AWS, GCP, Azure, etc. So you are basically, you can scale infinitely, you can manage state quite easily, you can manage secrets, you can manage infrastructure provisioning, and so on. So applications designed to take advantage of the features provided by these cloud vendors are basically known as cloud native applications. And then cloud native application, when you are putting an application together, we see it's based on microservices, and then there's a container, maybe orchestration involved to orchestrate the flow, the scaling, etc. And then on the deployment front, we see this immutable infrastructure, right? And then when you are deploying changes, we see you have to build another container. So there's whole process involved to do immutable deployments. And then, declarative APIs, you define the state that you want to be in, and the underlying framework handles the changes if there are any. And again, the benefits, as we kind of went through, the benefits that you get from the cloud providers, right? So the promise of scalability, promise of resiliency, flexibility, faster time to market, and so on. So typical brownfield application transformation. So when you are going from a monolith to a microservice architecture, now you don't have these layered patterns, right? You have on the right-hand side is basically a monolith transformed or refactored as a domain-driven design architecture. And this is an architecture from like Choreo. So we'll go through the Choreo example in detail. So you see kind of the edge APIs becoming gateway APIs exposed from the external facing gateway. Domain APIs becoming kind of domain, within each domain you expose APIs that can be managed interfaces within the API, within the cell or within the domain for other services to use. And then utility APIs becoming their own kind of container kind of domain or a cell in cell-based architecture. Again, when we are going through the example of cell-based architecture and Choreo, we'll go over these aspects. And then if you have systems of records, the system of records also can be inside their own cell, or sometimes what we see is in the domain itself, you have a system of records or the databases that are dependent on those services deployed within the cell as well. So the tooling landscape, for a lot of the time, microservices, basically the promise is the tooling makes all the things easy, right? But this is a diagram from the Cloud Native Computing Foundation, or CNCF. And then if you look at on the top left-hand corner here, it's basically the database technologies that's in CNCF. And then streaming and messaging and application and image building. So you have about 15 to 20 different choices that you have to choose from when you are designing an application, when you are choosing a database technology. And it's not always easy to figure out what is to use based on this, because the choices are like very large. And then typical challenges that we see is basically when people are moving or developers are moving to a microservice architecture, the technology complexity is kind of, a lot of developers are surprised by the complexity that's involved, especially if you're adapting to something like Kubernetes, right? So everyone basically talks about Kubernetes, but practically being able to adapt Kubernetes and then being able to run production workloads is a lot of work. What we usually see is that you basically get a managed service from a cloud provider, which is very easy to manage, rather than running your Kubernetes cluster on your own. And then it's very hard to find seasoned technical engineers who are like good platform engineers to be able to manage a complex infrastructure. And then, of course, the resulting factor is that its changes to the platform is going to be slow. So you are ultimately quite slow to go to market. And the choice is basically of organization or CIO's face is, do we continue to build this platform, or should we just buy something like off the shelf and then be productive from day one, right? Again, so here, there's no right or wrong answer here. For some organizations, it makes sense to kind of build the platform and then own the platform end to end. But some organization, it makes sense based on the domain they are in, just buy a ready-made platform and then build their applications on top of it. So analyzing architecture trade-offs is basically, so we'll look at this hotel reservation system. So there are like use cases when you're dealing with a hotel reservation system, that you can reserve a room, you can do a search for a room, and then you can cancel a reservation, right? So when I was researching this problem, so what I did was I basically went to Claude and then ChatGPT and then wrote it and asked, I'm doing a hotel reservation system, what are the architecture patterns that I can use, right? So the answer that's generated is basically there's no right or wrong pattern. So basically it says it's based on your use case, it's based on the scenario, and based on the kind of the trade-offs and the constraints that you have for you, right? So usually this is where kind of ChatGPT or like generative AI fails, and the experience of the domain and the experience of the architect plays a key role, where you have to choose the right patterns for that specific use case, right? And then again, if you look at the room reservation use case, you can implement this in various ways, right? Again, there's no right or wrong answers. It all depends on the use case and the constraints that you have to deal with, and the flexibility that you expect or the business expect from the system. So first is basically like a simple web app doing an HTTP call to an API, that API talking to a database. And then similarly, the next one, web app talks to a BFF API or a backend for front-end API that wraps maybe several other services. And the BFF API talks to the backend services via gRPC, talks to a database. And then on the last one, basically, again, web app making a call to an API, and then the BFF API publish that event into a topic, and then there are consumers who pick up that message and then do stuff with it, right? And another trade-off is at a technology choice or technology selection at a more granular level. What technologies or type of technologies that you should use, right? Whether you should use REST APIs for your scenario, whether you should GraphQL, again, gRPC. So again, there's no, all of these factors come into play when you are designing and architecting a system that specific to your scenario, right? And then the database choice is, again, you have multiple choices to choose from. If you use, like, for example, GCP, there are like 5-6 different database technologies available based with varying degree of capabilities, feature set. You have to choose the right technology to use, right? And then even after that, there are still a lot of factors that an architect or a developer has to deal with, like you have to deal with now endpoint management, and then securing endpoints, and then being able to discover all these other services, and then user authentication and authorization, and bunch of other things, right? So we didn't even get to these aspects. So the promise of tooling, does it really make easy, right? So what I did was here, the use case that we talked about. So I have a web app, and then talks to the hotel reservation use case, like a backend front-end API, push that to a topic, and then there's a consumer who picks it up and then write it to a database. So if you use like plain Kubernetes, I had to write, this is on top of building the actual service, pushing it as a container, and pushing it to Docker Hub. And then I had to write this YAML files, right, for each of these components, and then basically deploy all of these separately into a Kubernetes cluster. So the complexity that's involved is very, very high, even though the promise of tooling is basically to make this process easy, right? And then basically, this as a developer on the left-hand side, you write some code, and ultimate goal is you want to get this to production as soon as possible, right? And then this is the middle part is like kind of the messy middle that we are always talking about, with all the technology choices, decisions that you have to take from runtime architecture to CI/CD pipeline strategy, environments, security operations, monitoring management, all these complexities in the middle, right? And then this is kind of the slide that Sanjeev talked about earlier. Right now, a lot of companies, a lot of developers are focusing on the left-hand side, where they put a lot of focus on building the platform. What we want to do is shift to the right, where companies, organizations can focus more on the application and then kind of forget about the platform complexities, right? And that's where Choreo kind of comes in. That will kind of ease up all that platform complexity. So we'll go through an example here. I think it's about this practical session next. We'll see how Choreo makes it easy without you having to know anything about the infrastructure aspects, writing YAML files, writing like Docker files, all of these things. Yeah, I'll hand over to Chatura to take you through the application.
This mic is open. Okay. So Chintana already walked you through the cloud-native design principles and best practices and patterns. So when you develop your own platform in any manner, basically you will be using a combination of those patterns. In this example, we are trying to build this particular hotel reservation system using our internal developer platform product, which is called Choreo. So in this case, you will see you don't have to worry about choosing right set of patterns or right set of tools, because we have already done that for you. And you are not accountable of maintaining the synergistic operation between these different technologies that we onboard within this particular platform as well. So let me focus on the example first. So we have published this on GitHub repository as well. If you want to try out this particular example, you can scan this QR code or go to this URL and access the GitHub repository, where we have put all the resources that we are using during this particular session. First of all, let me give a quick introduction to the business scenario that we are going to develop using Choreo Internal Developer Platform product. So this is a typical scenario where a customer tries to make a reservation through a hotel system. So in this example, you can see, first of all, the user must try to gain access to hotel data in order to make a reservation, because obviously the customer wants to know what are the available rooms depending on their search criteria. For example, if they want to book a room for 2 guests for maybe a few nights, that information needs to be available on a system provided by the hotel. In order to do that, the hotel needs to provide some sort of a smooth login experience. If you have used these kind of similar applications, you have noticed these systems are typically integrated with social login kind of login mechanisms that has to be provided by the hotel system as well. And then when the customer makes a booking or cancellation, performs a cancellation, the hotel system should send a notification confirming that action as well. So those are the things that we try to demonstrate during this scenario. When we think about the systems that needs to be developed in order to make hotel data accessible and allow customer to perform these operations, first of all, you have to think about the systems of record that the hotel has, which is typically a database or set of databases. On top of that, you will have to implement certain services in order to make these data and operations accessible to any other systems or users. And then when you think about the user experience, basically you will have to model your application, the customer-facing application, in the form of set of APIs maybe, because in typical scenarios, you will have to either fund these APIs or fund this experience using a mobile application or web application kind of different user facades. So in this example, we have selected certain technologies in order to represent these boxes that I had at the bottom of this diagram. So you can see, as the system of record, we are using a MySQL database. And on top of that, you can see there's a Spring Boot service that we have developed in order to mimic the domain APIs, which should allow basic create, delete, update kind of operations. And then in the UX side, you can see we have a React.js based front-end application to provide the user interface to interact with. And then this React.js application is coupled with a GraphQL API. For example, if your web application has multiple user interfaces where you basically get the same set of data every time from the database, but by reducing certain fields. So in such kind of scenarios, GraphQL is a great choice. So that is why we have added that as well as a technology in this particular demonstration. And on top of that, you can see something called Asgardio. If you remember from the keynotes, this is the SaaS-based identity and access management platform that is provided by WSO2. So in this particular example, we are using Asgardio to provide the user authentication capabilities to React.js application. If you have done developments of user-facing applications, like the front-end applications, probably you have developed many user login screens in the past. But in this case, I will show you how quick it is to develop or integrate a login screen using Asgardio when you deploy a React.js application on Choreo, internal developer platform. First of all, I'm just talking about this scenario because when I go through the demo screens, you will understand what I'm trying to do there. So first of all, I will be talking about the project structures provided within Choreo in order to represent your applications or group your applications. So if you're familiar with principles like domain-driven design, basically this project structure provides you a capability of grouping a certain set of application components based on a particular domain. So in this case, our business domain is making a hotel reservation. So we will be grouping all the necessary components within this project structure, which is represented in the IDP as a cell. I will discuss this about this in detail when we go through the demonstration. And for the front end, we have a React.js application. So the idea is to develop this React.js application to communicate through the GraphQL service in order to access information from the database. And during the demo, we will be adding multiple other components as well, like another API developed using Spring Boot. And this will also be talking to the same MySQL database in order to create, read, and delete update operations. And also, when a booking or reservation is made by a customer, the Spring Boot service will send a notification or send a message to a Kafka broker where it persists this notification message as well. After that, we will be slowly adding other components to this as well. I will discuss about these dependency connections. For the time being, just remember, this is a way of communicating to these backend services or behind the React.js application. But I will be going through the details during the demonstration about this dependency concept. And then we have another component in this demo setup, which is a Python program, which should read the messages published to the Kafka broker and send an email to the customer confirming the action through Azure Communication Services email. That is our demo setup. And I also mentioned about Asgardio in this case. So within Choreo, because Choreo and Asgardio are WSO2 products, within Choreo, we can create an identity provider to represent a certain thing in Asgardio. Using that option, when you add your users to Asgardio, this user information can be used within Choreo in order to allow login to your applications in this manner. So in this case, you can see it's the same organization called Luxury Hotel. And we have Choreo and Asgardio. Within Asgardio, we design the user journey related to login experience, where they create the customer account, and we can create an application to have a certain client ID and secret in order to use this user information within the context of Choreo. And within Asgardio, you can develop your login journey by adding multi-factor authentication, single sign-on, or social login like Google. You can do anything which will be prompted on the login screen afterwards. So let's go to the demo setup. So first of all, let me show you the user interface of Choreo. So under Choreo, just like I mentioned earlier, we have this organizations concept. There you can see there are multiple organizations. First of all, let me show you this dependency section, because in this example, we will be using a MySQL database deployed on Choreo itself. It can be an external connection as well, but Choreo also allows you to create databases. So let me log in. In this organization, I think I have a database already created. So just like that, you can go to this screen and create a database. Similarly, if you want to spin up a message broker, you can do that using these dependencies as well. Those are the basic requirements in order to develop this particular example if you go through the repository. To demonstrate this scenario, we have created this organization called Luxury Hotel. So this is our main project in this case. And for the time being, I have two projects deployed here. If I go to this architecture diagram, we have two projects. And if I go to one particular project, you can see this one particular project is represented by this cell. During the Chintana session, Chintana already mentioned about the patterns and design principles that you can follow in order to provide a pragmatic way of developing microservices architectures. This is one of them. During the keynote sessions, you probably heard about the cell-based architecture, which is something we have followed when we designed this project structure. Within this project, you can have any number of components that are relevant to your business domain. There's no technical limitation, but if you follow something like domain-driven design principle, you can group your existing components into one particular cell. And this cell has two gateways to communicate in this case. So every communication will happen through the gateway when accessing the internal components. Let me show you how to create components in this case. I have also created this duplicate hotel reservation project, which is very similar, but I have reduced the number of components that I have created already because I want to show you how to create new components as well. So in this overview section, you can see there are two components already listed. I'm trying to create a new component now. So you can, when you create a new component, you can select a particular type. You can see there are service types, web applications, event handlers. Those are the things that I have used in this particular demonstration. First of all, let me create that GraphQL service that I showed you earlier. For that, I am using this GitHub repository. So this is the URL I provided at the beginning, where I have listed all the necessary components. And this can be any technologies. You just have to put them in a repository and point that when you create a new component. Let me authorize this with GitHub. I have already logged into my GitHub account, so it directly goes to this particular view, which allows me to select the repository. And select the necessary component, repository, the directory, like this. So this is the GraphQL service that I have used, that I'm deploying here. So this, the technology behind this is Ballerina. So I'm selecting the Ballerina build pack in order to build a container instance by encapsulating the source code fetched from that particular repository. So when you try to create a component and put them into a certain runtime environment, basically you will have to provide some environment variables in most cases. For example, certain URLs, usernames and password kind of parameters you have to provide before promoting that into a particular environment. And typically, these parameters can be different from development environment to the production environment. Such things also can be provided after the build during the deploying time. I will show you that in a minute. Yeah, you can see the details of this build, and it has been built already. Now we can go to the deploy section, where we can provide the configuration values and deploy this. Let me click this first. Then it prompts me with a view where I can include these variables before the deployment. So this can be something, this particular program is written using Ballerina, and we have a particular way of providing this kind of variables before putting that into the runtime. But if you use program like Java, Spring Boot, or any other technology, there are ways to provide environment variables. For example, if you export environment variables using a console before you add that to to the runtime, I will show you another example where we can provide any kind of environment variables in the form of key value pairs as well. So I have this information already. Let me copy them. Now you can see in the development tab, it's deploying the relevant artifacts into the deployment environment, the development environment. Yeah, now the GraphQL service is ready in the development environment. And let me add the React.js application as well under the components. For that, I'm choosing this web application build pack, the web application type, and then React.js build pack for this. So this is the directory related to the web application.
I think Chatra, in the kind of the build process,
yeah,
it's basically we didn't do any Docker, we didn't write any Docker file, right?
Yes.
So we just choose the build pack, and then the build pack knows what technology the program is written in, trigger the right build. Like for example, Java you can use Maven or Gradle, right, as your build process. So the build pack is intelligent enough to select the kind of the build and then trigger the build. And then after a successful build, it automatically builds the Docker container out of it. And then it pushes and after the Docker image build, we automatically do a Trivy vulnerability scan on the image. So if there are any CVEs reported against any of the libraries in the Docker image, the build would fail. But if you really want, until there's for example, if there's a third-party library that you don't have any control over, you have the option of overriding it until a fix is available. And then what we do is, after a successful build, we push the image into an internal image repository. and then at the deployment time, we pull the same image and then deploy it so that each environment is running its own Kubernetes cluster underneath. So we deploy that image into that Kubernetes cluster.
Yeah, I think because of the slowness of the internet, it is not visible until it becomes visible at once. But in this panel, it exactly describes every step that is relevant to the build.
And if you switch to a successful build, and then if you go to the build section, you can also get the full build log basically. And one of the other advantages here is that, so developers usually do the build on their local machine, right? So this build we do here, it's on a kind of a clean environment to make sure there are no, so this is basically doing a deterministic build every single time that you are pushing a change. Also, I think if you see the option there on the build section, it says auto build on commit. So you can choose to turn that on. So whenever you commit to the repo and then push a change, it'll automatically trigger a build for that change. And then automatically deploy it to the dev environment as well. So the moment you push a change, your change is available in the dev environment. Yeah.
Thank you. Is it possible to put our library like Artifactory for the build image, or we have to use your set?
Yes, right now, basically, you won't see that configuration here. So we support what we call setting up a private data plane. So the entire runtime will be, you will be able to install it in your kind of a cloud account. And then in there, when you do the build, we can basically talk to your private Artifactory repo and then get the necessary libraries.
Okay.
Yeah, I think you partially already answered for the artifact library. And then when we have to do a rollback to the previous version, so all the versions of the previous build, so they are maintained in, let's say, the internal artifact repository you have.
Exactly, yeah.
Okay. And do you also offer a possibility to go back, let's say, 2 versions back from the drop-down? I can select the version which we want to deploy?
Yes. So right now, how do you roll back is that, Chatru, can you go to the...
Yeah.
So if you go to the build section.
This right?
On the build section. Yeah, show commits. So you can choose like a commit here and then do a build here. And then you can promote that build you can deploy that build into dev environment.
Thank you.
Okay. So let me go to the next part, which is making connections to the already running services from this web application. So in this section, under this web app, when we go to connections, the connections, under connections, you can select these services in order to create local links to the existing backend services that we have developed. For example, if I choose GraphQL service that I have developed already, and I can create a link or connection so that it could, the web application could connect to this backend service called the GraphQL service through a private connection, or within the project it can connect to this backend. give some name. And here you can see the local URL it provides. So this can be used within the web application configs in order to make a private or secured connection within this project to the backend service. So similarly, I will have to create another connection to the Spring Boot service as well.
So while Chatru is doing that, I think if you are doing like platform engineering, you are building this platform yourself. To make this work, you basically have to, in the development environment as well as on the production environment, you have to inject the right variable, right? So we maybe create an environment variable and then point to the right service at that environment. So basically this process that we are doing here by creating a connection, we do that automatically. So at the deployment time, from the web app container, we would inject these variables saying these are the dependent services, and then you can talk to these I think Chatra will demonstrate here. You can talk to these dependent services through a context path.
Yeah, in this example, I mean, we are referring to two backend services. These are not the exact URLs, but I have to copy from the connections to get the exact URLs. But in this format, you can provide the relevant URL to the Spring Boot service as well as the GraphQL service that we have created, so that it would communicate to these backend services using a local connection rather than going through the internet.
Yeah, and in this URL, you can probably note that the domain name is not there, right? So we only have a context path. So usually in a production environment, you would have to have the full URL, right? So what we do here is that maintain the context path, and from the deployment, the gateway, we resolve the correct domain automatically, whether it's a dev environment or the production environment, or maybe you have other environments. So we kind of infer that information dynamically from the gateway.
Yeah, so this is exactly the same project repository. It's a different project, but it uses the same repository in order to build this particular application, which is represented by this architecture diagram. Here you can see the notification service, which is the Python program that I mentioned earlier. I have already deployed this Python service and some of the artifacts like the Spring Boot service. Yeah, web application is there and it can communicate with the GraphQL and the Spring Boot service through local communication.
Another thing, sorry,
to interrupt. Go ahead.
Another thing is basically, if you go to overview section, you can see set of components there, and then when you scroll down, you can see a README file, right? So what we have done here is that usually, if you are maintaining a kind of a monorepo approach for all of your this is your set of services, maybe a web app and other dependent services. Doesn't have to be a web app. It can be a bunch of other microservices as well for a certain domain. You would have that in a Git repo, and then of course you would have a README saying that maybe this is how you should run it, these are the dependent services and all. We can basically take the entire repo and then model it in Choreo. So whatever that's represented in your source is basically now available in Choreo at a kind of a runtime execution level as well.
Okay. Yeah. So I think for that, yeah. So this is the same README file that was available in the repository that I shared. So it has been published here under this components, just like Chintana mentioned. It's the same README file.
And I think for monorepo especially, you don't have to create each and every component manually. We also have create like option to create multiple components at once. So here, when in the drop-down, when you select create multiple, and then give the repo, you would see multiple different service options saying you can select these are the 3, 4, or 5 services that I want to deploy, and then it will create these at the same time. So you don't have to manually go and create each and every service one by one.
Okay. One thing I couldn't show you yet is the environment variables provided with these other components that I have already deployed here. In this manage configs and secret section, you can see these environment variables. So these are typical key value pairs that you would use with export command in the terminal when you run some application on your local machine. So just like that, we can provide environment variables using this section. For these 2 services that I had deployed, I have provided basically the database parameters as well as Kafka broker connection related parameters and Azure communication parameters in the form of environment variables. Now let me go to the
sorry, Chandra.
Yes.
And in the deployment section, right? So
Yes.
when Chandra was viewing the configuration, there you could see the password as plain text, right? So we have option where you can mark a text field as a kind of a sensitive value. So when you view the configuration, you won't actually see the plain text value. It'll be masked with kind of like stars.
Is it also possible to link an external vault?
Yeah, so what you see here is basically when you sign up to Choreo, we automatically give a runtime for you. So this runtime is a shared runtime that is running on Azure, and each development environment and production, we are running 2 different clusters. So you have the option of installing the runtime in a cloud account you own, Azure, GCP, Amazon, etc. So when we are setting up, like for example, in Amazon, we'll use Amazon's key vault. So also on-premise, for on-prem deployments, we support Vault as a default key store. So if you have a Vault installation, we can integrate with Vault.
This is the section that Chintana mentioned already. So if you want to put a password, you can mark this as a secret. Yeah, that's another thing that you can do under configuration. Yeah. So now I can launch my website, the web application. Before that, I couldn't show you another thing, which is related to the login screen. But let me go through the web application first. And after that, I will explain how it directs to the Asgardio-based login screen and how it uses the Asgardio for login. There are some configurations as well. So this web app, let me launch this web application first. Yeah. So according to what we depicted so far, once any action is performed on this website, it is supposed to send an email to the customer's given email address. For that, I'm using a dummy email account. Yeah, I can launch this website using this URL. And when I try to log in, it directs me to the login screen provided by Asgardio. I will show you the relevant configuration for this. So once I logged in, it goes back to the application home screen, which I have provided. And let me search. So these are the available rooms for these 2 dates, the check-in date and the checkout date given. And search criteria also included the guest capacity as 2. So let me press this reserve button. Now I can provide a phone number and make a reservation. So now it's supposed to send a notification email to this email address. Yes, you can see this email was received, and if I perform another action, basically it does the same, like deleting. Just like that. So let me explain the case related to the Asgardio. So in this case, you can see this organization name is Luxury Hotel. And on Asgardio also, I have an account. And I can choose the same organization. Yeah. So this is called the Luxury Hotel again, this organization. And under organizations, I can create applications in order to facilitate these applications with the login capability. If I go with this one, called Luxury Hotel Connect, under protocol section, you can see there's a client ID and client secret provided. I have selected certain grant types, and based on the application that you develop, you will have to provide the relevant redirection URLs as well. So these are the URLs relevant to redirection after the login and logout actions. And I have to provide these values in order to bind this application to my React application. So within the React JS application, you don't have to do anything other than using Choreo console in order to provide this capability. So this identity provider section provides you with a few available identity providers. One is Choreo built-in identity provider. The second one is the Asgardio, and you can see the same organization, Luxury Hotel, listed in front of Luxury Hotel. And the client ID, the same client ID that I can see here. And when configuring, you have to provide the client secret as well. So after you provided that, it basically disappears. What happens is, as the developer of the web application, you just have to provide the route URL similar to what I'm trying to show you now. In this logic, if you are familiar with React, you can see, yeah, you can probably see this section. So once you provide these routes, basically, if there is no any valid login in the browser, it redirects to the login page provided by the Asgardio. And once you signed into the application, it basically stores a cookie with user information, which you can use in order to get user-related information into your application context. And within Asgardio, you can model your login flow as well. So here we have a basic flow, but you can integrate social logins, add multi-factor authentication. You can design your login journey using this particular user interface. So if you have hundreds of web applications, you don't have to design login screens again and again because it can be modeled on the Asgardio console and utilized within the Choreo deployments as well. Yeah, that covers everything that we intend to do during this session. Do you have any questions or any areas for clarifications?
Hey, thanks for the presentation. One question I had is about the deployment process. For example, I see this as console choreo.dev. I don't know if that's like your internal sandbox or basically like when you go to the deploy section here and you've deployed to development but not production, how does this differ from this Choreo instance being in development? So
you mean the environments?
Yeah, so like when you deploy this development instance to production, you'll have your application deployed in dev and prod, right? What about Choreo itself? Is it just a single instance, your production environment, or do you also have Choreo running in dev and production?
That's in one environment.
So basically, we have Choreo in dev and also prod. So the one you see here is our production instance. We run a dev instance in a kind of a private IP that where we do feature development, test on the dev instance, and then promote to production. So the promotion process, the feature development process, now we are at a stage where we are releasing continuously, like every single day.
Okay, and so is that only internal to WSO2, or as a customer, if we used Choreo, would we also have a dev instance and a prod instance?
Right, good question. So as a customer, so that is the process that I explained is basically internal to WSO2. That is how we release features to Choreo. As a customer, when you are using, you would use console.choreo.dev. How you differentiate your workloads is basically with the development and production environments. So like if you take a Spring Boot service, you would have that Spring Boot service deployed on development, where you would test your code basically, and then promote it to your production environment. So those two will have different URLs.
Got it. And I assume we could have more than just development and production.
Absolutely. Once you create a UI account, you can go to the settings, and then you can create different environments however much you want.
Perfect. Thanks.
This is an example. Under this organization, we have custom environment in addition to development and production. So just like that, you can add more environments.
I have one question also, because you did a couple of custom configurations in Choreo. So in the end, do you also generate, let's say, a configuration file, like wherein then all the configurations are managed as a code, like we do with Terraform and all this for platform as a code?
Very, very good question. So we are not there yet. So we have a plan. All the deployments that you do here is basically commit to a Git repo, where you can do basically kind of deterministic deployment based on that. But it's not there yet. It's in our roadmap, probably.
I mean, let's say.
I think your question is more about the initial scaling parameters and everything maintained as code.
Yeah, and also some configurations wherein we provided, let's say, the DNS, or let's say some additional configurations where we were configuring the app. So now we did manually, and let's say worst case scenario, if we lose this part, like how can we recreate or reconfigure the application again?
Sorry, I didn't get it.
Yeah. So basically, one part of the question is, so Choreo itself can take a downtime. So we back up all the data that, so basically all the when you deploy a workload, we generate internally like a Kubernetes artifacts ourselves. We don't expose that to the developer here. So since we have a backup of that, when we bring up a new environment, we can just run that same deployment descriptor, and then it will have your services. So that's one part. But if you have your data stores also in Choreo, that probably you have to back up separately. So again, so this experience that we showed today is basically doing all the component creation, deployment, etc. through the web UI. Right. So we have a CLI experience as well. So all the actions that you can do through the browser can be done through the CLI. And also the same experience is built into VS Code. So without leaving the IDE, you can connect to your org, publish your code, get the build logs, get the deployment information, promote to other environments, etc. from the VS Code as well.
Thank you.